नशे से चढ़ गई ओए कुड़ी नशे से चढ़ गई पतंग से लड़ गई ओए कुड़ी पतंग से लड़ गई ऐसे खींचे दिल के पेचे गले ही पड़ गए ओए नशे से चढ़ गई ओए कुड़ी नशे से चढ़ गई पतंग से लड़ गई ओए कुड़ी पतंग से लड़ गई Isn't the best place to find a lover, so the bar is where I go. Me and my friends at the table doing shots, tripping fast and then we talk slow. Come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop, find the man on the jukebox, and then we start to dance. And I'll sing it like I want your love. Your love was handy for somebody like me. नशे से चढ़ गई ओए कुड़ी नशे से चढ़ गई पतंग से लड़ गई ओए कुड़ी पतंग से लड़ गई I'm in love with the shape of you.
Good evening, Dr. Sadikin. I'm Ranggita.
I am Leun.
From 3 we would like to share with you our first labs part A and part B result. This is mechanical system. The parameters are given in the lab sheet. We will be getting approximately 2 equations according to figure 1 in the lab sheet. It's actually a 2 by 2 matrix, and the line number 13 is x1 and line number 14 is x2. As it's stated in the lab sheet, in part A, we need to find for transfer function of x1 per f and x2 per f. A1 is x1 per f. So in order to get x1 per f, 0 and f will be in the first column as it comes from the output. For x2 per f, we must replace the 0 and f at the second column. To find the x1, the formula will be determinant of a1 per determinant of a. We can see the equation of x1. We can see the equation of x1 in the same line. To find x2, the formula will be determinant a2 per determinant a. The equation of x2 is also in the same line. In order to simulate x1 per f, we declare the numerator and denominator which is already stated at x1. Same goes to x2. The step plot is for unit step response. Then we just run the coding. So we get this step response graph. We can also evaluate by section.
Ranggita,
Yes.
I have a questions. In the step response shown, which one is x1 and which one is x2?
You tell me.
I ask you.
I think the blue color line is x1 and then the red color will be x2. Is that correct?
Are you sure?
I'm not sure, Maki.
I think you have to elaborate the intersections to know which one is x1 and which one is x2.
What is that? Come again?
Elaborate the intersections, the part of x1 per f. The one, the numerator one, yes, this one.
I said the blue color line is x1, right? Yeah, see?
Yeah, it's true.
Then it will be both also in,
To combine it.
will be in.
Okay.
Okay. Yeah, let's go for simulating. Okay, this is our simulating. Here we use the transfer function and state the equation. Then we choose unit step and scope. In our coding, we had two equations, so we also do the two transfer function and connect it to the unit step and scope. We will get the same result as previous coding simulation. This is our result.
It's a bit slow, if you don't mind.
Yeah, it is. Okay, this is our result. It's same thing like the coding just now. Okay, let me make.
Okay.
Part B, electrical network. As we can see, the parameters are given in the lab sheet, and it also says that the input is VT and the output is VLT. In figure 2, there are two mesh loops, which means it has two equations. First is I1T, and the parameters related to I1 is R1, C1, and R2. Line number 13 is the equation for I1T, and this part is the common thing between I1T and the I2T. Same goes to the I2T. The equation at the line 14, and this part is the common thing as I said earlier. Our main purpose is to find VLT, which is at I2T. That is why we replace V and 0 at line 17 and 18 to find I2T. I2 is actually determinant of A2 divided by determinant A. We can see the equation in the same line. The formula to find VL is S times with I2. The last four line is just the numerator and denominator of the equation that I explained above. If we run this, we will get the transfer function equation and also the graph step response.
Yeah.
So run this. This is our graph. Just let's evaluate by section. This is our common window. Okay, then let's go for part B simulating. As usual, we must put the transfer function. The equation is from the coding, unit step function, and the scope is raised, and we have to run it to get the same graph as the coding simulation. Okay, let's run it. So here we know that the both graph are the same graph. That's all from us, Dr. Tarikin. Thank you very much.
Thank you.